All right, so we're going to go through, we left off at lesson 10. If for some reason the video runs out of time because they can only be so long, I'll just make a second one and finish up the lesson. So you might get this in 2 different links. So I'll let you know if that happens. So this is kind of where we left off. The first one, the original problem is 3 over the square root of 2 minus the square root of 5. And then what they did is they multiplied the square root of 2 minus the square root of 5, and we're multiplying that by the square root of 2 plus the square root of 5 on both sides, because when we multiply the 2 binomials like that, they're going to cancel out. So on the top, you just have your 3, and then your parentheses, square root of 2 plus square root of 5. On the bottom, it's like you're doing FOIL. So square root of 2 times square root of 2 is right here. Square root of 2 times square root of 5 is right here. And then we're subtracting, because we have a subtraction sign right here, square root of 5 times square root of 2. And again, subtracting again, because we're right here, square root of 5 times square root of 5. And when we do that, again, our numerator stays the same. These 2 sections right here cancel out because we have positive 2 square roots of 5 minus negative, or so minus 2 and 2 square roots, 5 square roots. So these 2 middle sections cancel out. Square root of 2 times the square root of 2 is 2. Square root of 5 times the square root of 5 is 5. And we have that subtraction sign right here, where's where we get that. Simplify our denominator to negative 3. Then what I'm doing is I'm just canceling out my positive 3 and my negative 3, and that gives me a negative 1 up here on top. And then we can really get rid of the 1, and it's just negative. And so, and that distributes. So it's negative 1 times the square root of 2, which gives us negative square roots of 2, and negative 1 times the positive square roots of 5, which would give us the negative square roots of 5. So that's that one.
Here's another.
So the next problem that we have is 1 over the cubed root of 2x to the 4th y squared.
To ration.
And what we're doing here is we first change getting rid of the radical sign and giving us an exponential expression. And so we're putting everything to the 3rd power, the 1/3 power, I should say. So when we carry that over, it's going to be 2 to the 1/3. Since it was x to the 4th, it's now going to be x to the 4 over 3. And it was y squared, so now it's going to be y to the 2 over 3.
Then multiply.
Okay. Then what we're doing is we're multiplying our numerator and our denominator by whatever cancels out our fractions here. So for example, I already have 2 to the 3rd. To cancel that out, meaning canceling out the fraction, I would multiply that by 2 to 2/3, because 1/3 plus 2/3 is going to give me 1 whole. X to the 4/3, I'm going to multiply by x to the 2/3, because 4/3 and 2/3 is going to give me 6/3, which is the same thing as 2. And then y to the 2/3, I'm going to multiply by y to the 1/3, again, because 2/3 and 1/3 is going to give me 1 whole. Okay, because this one was already an improper fraction, we had to round that up to get to our next whole number.
Apply the rule.
So then, once you have that, we're multiplying our top. So our top is 2 to the 2/3, x to the 2/3, y to the 1/3. And then we're combining. So like I said before, 1/3 and 2/3, 4/3 and 2/3, 2/3 and 1/3. Our numerator stays the same here. This combines to be 1, so 2 to the 1st gives me the 2 right here. X to the 6/3 is the same thing as x squared, and y to the 3/3 is the same thing as y. Then on the top, what I am doing is I'm turning the exponential into the radical, and so all I'm doing is putting that denominator of 3 on the outside. I keep my 2 with my numerator of 2. Keep my x with my numerator of 2, keep my y with my numerator of 1. Denominator stays the same. And then the last thing that I did is I know that 2 squared is 4, so I changed that to a 4. And I know that y to the 1st is the same thing as y. So that is that problem.
Here are a couple of problems for you.
Okay, so the first problem that we have here is 9 over the square root of x plus 3. And so what we need to do for this one is to multiply both the numerator and the denominator by the square root of x plus 3. So when I do that, I'm going to have a fraction, and I'm going to have 9, and then I'm going to have the square root of x plus 3, and that's going to be over. And remember, when I do the square root of x plus 3 times the square root of x plus 3, the square root symbols cancel out, and so I am just left with x plus 3. And then just to double check, you can see how that work is done right here on the side. Okay. Our next problem is 1 over the 4th root of 8x cubed. This one is a little bit more difficult. And so what I'm going to do is, the answer is this, and I'm going to walk you through the steps, which will show up here on the side. So the problem that we are going to do, the first thing here is we take from the radical and we change it to the exponential. So I have 8 to the 1/4 and x to the 3/4, which gives me this right here. Then again, I want to cancel out those bottoms. So I'm going to multiply 8 by 3/4 because 1/4 and 3/4 will give me a whole. And x to the 3/4, I'm going to multiply by 1/4 because again, 3/4 and 1/4 give me a whole. So when I do that, top and bottom, I get 8 to the 3/4 x to the 1/4 over 8x, because then we get those exponents to cancel out. Then our next step right here is 8 to the 3rd is going to give me 5/12. And then I'm making that all to the 4th power. So I'm making that back into the radical. And so I keep my x. And on the bottom, it just stays the same. I'm breaking up 512 into 2 times 256. And I still have that x there. And then when I do that, I have the 4th root of 256 is 4, because 4 times 4 is 16, times 4 is 64, times 4 is 256. So that's where I pull this 4 out right here. And then underneath the 4th radical, I'm going to have my 2x, and my bottom is going to stay 8x down here. And I know it's really hard to see. I can't scroll on my screen to show you that, but it really is down there. And then the other one that I have here is going to be this simplifies, because the 4 right here and the 8 on the bottom are going to cancel or simplify. So the 4 cancels out, the 8 turns to a 2, and so then I would have the 4th root of 2x over 2, which is my answer right up here.
Simplifying expressions with radicals. Generally,
so this is just the summary page, and so this again just tells us what we learned. I think that was on page 10, making sure this is kind of that FOIL, and so we're always multiplying so we get rid of any radical signs on the bottom. That's our goal, is to rationalize the denominator, thus the lesson, so getting rid of any radical signs. So here are some problems that we are going to be going through. So 100 to the 1/2 is the same thing as square root of 100. The square root of 100 is 10, because 10 times 10 gives me 100. And then you can see the additive inverse right here. Sorry, the additive inverse right here for the rule. My next problem is 1 to the 1/3, which means what is the cubed root of 1? And that's going to be 1, because 1 times 1 times 1 gives me 1. And again, if you want to see that, it's that same rule that we just talked about the last time. The next one that we have is the 4th root of 256, x to the 10th, y to the 12th. And just so you know, my time is going to run up, so we're going to try to take off here really quickly. But this answer is going to be 4x to the, Actually, let's just stop with this one and hopefully we can pick up